5 reactions of alkenes. Well, first of all, let's address the apparent paradox. Alkenes are much more reactive than alkanes. Now, alkenes have a carbon-carbon double bond, so you'd think that would make them less reactive. After all, takes a lot more energy to break a double bond than a single bond, and yet they're more reactive. Well, the reason why is that alkenes are susceptible to electrophilic attack. Those 4 electrons there, high concentration of electrons, which means that electrophiles are going to be attracted there and cause the molecule to react. I'm going to look at the 5 reactions, but you don't need to know why they are electrophiles, the chemicals that we're going to look at. That's a higher level concept. And just to recap, electrophiles react with nucleophiles, and the electrophiles grab an electron pair, take an electron pair. All 5 reactions are addition reactions, where 2 reactants become 1 product. 2 becomes 1. This has 100% atom economy, and that has the benefits of green chemistry. Not to be confused with substitution reactions. Here, part of a molecule is switched out with one of the reactants. I think substitution is swapping, the swapping of components in a molecule. All right, so for 4 of the 5 reactions, I'd recommend doing it this way. Then even the trickiest questions I ask you, you can adapt this to your answer. All right then, so for the reactions, let's start off with hydrogenation. So hydrogenation is adding hydrogen. So that makes sense that I'm going to have a hydrogen here and a hydrogen there. Always goes on the left and the right. So I'm adding hydrogen and a platinum catalyst. That's hydrogenation. Next up, after hydrogenation, is hydration. Don't get those confused. Again, I'm going to add half of the molecule on one side, half on the other. So that's adding water. The catalyst is a phosphoric acid. No one's quite sure if you have to know that. And so that's hydration. So in the first case, I made ethane from ethene. And in the second case, I've made ethanol. It gets a bit messy, but you've got to get it all on one page. Looking down to the third one, I can pop a halogen on here and a halogen on there. So that would be adding chlorine, and that would be halogenation or chlorination. This chemical is dichloroethane, and you do need the numbers because there's 2 isomers, 1,1, and in this case it's the 1,2. Sometimes they ask about that. And for the final of these 4, I can have a hydrogen here and then a halogen there. So that would be just adding, for example, HF. And that would make a fluoroethane. What about the 5th one? Well, that comes up later. The IB is not going to ask you about ethene. It's too easy. But let me show you how you can turn this simple table, this simple kind of grid, into the more complicated ones. But first, I'm going to need to tidy it up a bit. Okay, so they're going to ask you not about ethene. That's too easy. Maybe they'll ask you about propene. So all you've got to do is consult this grid and then add that cheeky CH3 everywhere. And now you've got the answers for the addition reactions of propene. So now it looks like we've got propan-1-ol over here. On this side, I've got 1,2-dichloropropane, and on and on and on. They could make it a little more complicated. What if they chose, instead of propene, butene? Well, that's not butene, that's but-2ene, but that's okay. Just add the cheeky CH3 all the way along, and now you've got the answers for the addition reactions of but-2ene. What challenges some of my Smarty Pants students is what if they ask about but-1ene? So I'm going to reset the diagram and see if you can turn the central one into but-1ene. My smarter students have trouble with this. Maybe it's my fault. There we are. So now that's but-1ene, this molecule here. And then you can press forward with the same technique. Just put C2H5 everywhere else. This is covered more expansively in another section of the syllabus, but just for completeness, polymerization of alkenes. They ask you two sorts of questions. So the first one is take 3 identical alkenes and polymerize them. That is, join them together. So the trick with that, and I've chosen the simplest one here, downwards, is the 2 electrons at the top of the double bond go in one direction and the other direction, to the left and to the right, to the left and to the right. And now I've got the monomer ethene turning into polyethene. That's too easy. They'd never ask you that. So using the same old trick, let's say that they wanted this molecule at the beginning. So what is that? 2-fluoropropene? 2-fluoropropene. Well, so that looks a lot more tricky. But you're just going to use the same trick. The other way they'd ask you to do it is to just draw the reaction out. They wouldn't specify that you need 3 monomers. So you draw out the square bracket of the repeating unit that is based on the monomer. How can you lose the points? If you don't put the square bracket, you don't get the 1 point. This is often worth. If you don't have the lines coming clearly out of the square brackets, you lose a point. And you still haven't got the point because you need n of those. N is an arbitrary number, a big number, and you need a little n down there.